Welcome back to the channel. Hope everybody's doing well. And in this video I'm going to take a look at this R1R2 Link lead that are used by electricians in the UK for carrying out continuity testing on the live and CPC conductors as part of testing for installations. Now, the lead's been around for a little while and there's a number of YouTube Sparkies that have done videos on this. The video that sparked my interest in this lead was from A1 Electrical Services, and Mr. Wayne, he did a comparison of the different connection methods for an R1R2 test using this R1R2 lead and then Q-Tech leads, connection blocks, Wago connectors and the like, and he did find there was a slightly higher reading when using this lead in comparison to those methods. He also discussed problems with parallel earth paths as well when doing this test on a real installation. That sparked my interest in this lead and what was exactly causing those high connection resistances. So that's the kind of testing that I'm going to do on this lead today. Now, when you usually use this lead, you'll be using something like the multifunction tester over in the right there from that's an RS Pro MT6600, but that has limitations. I'll stick a table of the common installation tests that are out there and the accuracy and the range that they've got on the low ohm function. That's specifically 2-wire testing, which is fine for testing installations, but for the tests I'm going to do, I'm going to use this MTR 105 because this offers me 4-wire testing capability instead of the 2-wire testing. And in the table you'll see that this can go down to 10 microohm against the 10 milliohm usually for a multifunction tester, although that RS Pro can go down to 1 milliohm. And in terms of accuracy, you've got like 1.5 to 3% accuracy for an installation tester against a 0.25% accuracy. So this instrument much more accurate, but in direct comparison it will use a 200 milliamp test current that you can see on the screen here, and it can also do bidirectional test as well, which is a similar manner in which a multifunction installation tester works. So I'm not going to go through all the tests I did because the battery won't last that long in the instrument and it'll probably get very boring. So I'll just put tables up as we go along for the different tests that I did, so the results here might be slightly different to the results in those tables. But when I first started out, the leads I'm using are Kelvin leads, 4-wire leads specifically for carrying out this kind of testing. I just tested to see what the actual lead resistance was in comparison to other leads. So we have this lead here, and we hit the go button. Now we'll see what we come back with. 11.54 milliohms. And in direct comparison, let's take the Q-Tech lead here and go on in there, and there. We'll go again. Yes, that's 9.86, so pretty similar to the R1R2 lead. Q-Tech also do a shorter lead, so put that one on as well. Go for that. .78, obviously a shorter lead, much lower resistance value as would be expected. Let's look at a standard test lead, just banana test lead that we've got here, and give him a go. And then let's just pull one of these leads out. So 18.85 milliohms, so standard 4mm banana lead is quite a bit higher resistance than general leads. You'll see in the table as well, I'll put it up now, that I actually tested a number of banana leads. These leads are actually from the RS Pro kit, and at the bottom of the table you will actually see some tests conducted with different methods of connecting to the banana leads That's these probes and jacks that I used here. I actually found that actually testing direct into lead gave me a best result. These gave me the next best result. These adapters here actually added in more resistance in, so all the tests I did with leads that I tried to connect directly with these Kelvin clips in the manner that I'm doing here, and this is the best result I got, but I did try other test methods, so we'll just do a quick comparison of that one. And you see I get an even higher resistance reading, and 30 to 50 milliohms is seem to be the result for the vast majority of leads of this nature that I tested. So that's that table there. In comparison to the rest of the leads, the nominal resistance on this R1R2 lead looks to be pretty good, to be honest. Nothing of any great concern there. What I then did in this next table, I've got I tested this lead 100, made 100 measurements on it, connecting in different manners, predominantly to the screwdriver tip that you see here. Some tests were across it in this manner. Some tests I went across the actual posi element of the screw head, if you like, the actual webs that go into the screw themselves. That on 11.61, but generally speaking it comes out fairly similar to all the tests. That's on one of the actual webs itself. 11.79, you can see it's pretty good. We'll go across the tip. 11.75. So you see there, and you look at all the values that are in there, they're all pretty similar. I also tried, you can get, I'm not going to be able to show this on camera I don't think, but there is a small bit of movement in this head against the magnet, and I did try and manipulate it around a fair bit and see if that caused any issues. And all those results are in this table here, but you see I had a spread of around about 3 milliohms across all the tests. I've actually made it better now, 10.33. So the lead itself seems to be quite stable. I was quite happy with those results. An average, I think it was just above 11 milliohm, as I say, a spread of 3 milliohm across all those 100 tests, which shows it's pretty stable. It looks to have been made pretty well in that respect. So that was those set of tests done. And once I had that, what I was then interested in is the actual resistance from this head onto these screw heads here. So I've got a number of different screws put into this block of wood, and we can seat the head in there. What I actually did to avoid this putting any weight on the actual screw head and affecting the result, I made all the measurements from the crocodile clip here, and then I can take the 11.3 milliohms average resistance reading I've got from the test result I've got and get an actual reading of the resistance between this and the screw head itself. So we've got 15.45 there with that one. You take the 11.5 milliohm, sorry, the 11.3 milliohm away from that, and you get the resistance that you have there. And we'll go on to, so that a posi 2 can be used on that, but that's more of a posi 1 screw head, I guess, there. This is an M5, which is typical what you'd get for a number 2 posi screw in there. And you've got 13.03 ohms. Again, slightly bigger screw head, so you've got more surface area connecting and giving you a lower resistance reading on that. So that follows a pattern, really. That's to be what would be expected. This is a Phillips 3 head, really, and you can see that there's a lot of play and a lot of movement in this. So we'll see how well a reading we get on this one. 17.21, and you can see it starts to go up a little bit. Move around, we'll try them again. 14.65, got again one that could well be me putting pressure on it there. and adding a bit more to it. So now, in all honesty, I've not seen number 3 Phillips in switch gear for quite some time. When you get to this size, it tends to move to cap head screws for the ones that I've seen, but yeah, 20 odd years ago, I was seeing sort of like 160 amp, 200 amp breakers. You'd have a Phillips 3 screw in there. So we'll go on to this slotted one and see how well we can get a reading on this one. So I'm not pressing on this, I'm just holding it in place so that it doesn't fall over. So we're actually trying to get onto the tip of the screwdriver bit here, and the instrument's going to slow down taking the reading. It does that when it sees a higher resistance, if it can record an actual value at all. So it doesn't seem to like that one too much, so I'll just disconnect and fail it. I'll just try it in the actual slot. See if we can get a reading there. Just fail him again. Try and laying him on top. See if we can get a better reading. It's probably gone now. So 50.85, but it's some very, very high reading in comparison to the others that you get. I'll try laying the actual web of the posi into the slot of the screw as well. Try that one. .59, so you get a slightly better reading if you lay this into the slot, but sat on the surface, it's not too heavy at all, and on the tip I am struggling to get a response from the instrument. Oops. Yes, sometimes it gives me a reading, sometimes it doesn't. It just doesn't want to play in front of the camera, does it? Which is typical, but you get the general idea, I think, from those tests. So where you've got good connection onto a posi head, it's fine, but when you get onto these slotted screws or a larger posi head, you start to see an increasing resistance in there, which is kind of what I would have expected, really. Just doesn't want to play, does it? Yeah, don't want to know. Okay, so we'll move on to testing some actual breakers in there. Do the first click. We'll leave it running while I pull these breakers forward and see if we can get a reading out of it. So I had a number of RCBOs and MCBs that I've begged, borrowed, purchased, stolen, just to go through these tests here. And there you go. So 673 milliohms on that one, and obviously it's not seated properly on the head. Doesn't like it, so you can't really use this on a slotted screw. It's going to give you issues, which is to be expected, I guess. But we'll put them out of the way and we'll do some tests on some MCBs. Now for these MCBs, I set my torque wrench to 1.4 Newton meters, because the breakers on these, it ranges from like 1.2 to 1.9 Newton meters. So I didn't want to over tighten any of the breakers too much. So first one, what I will do, again, I've got a table that I can put up of the results of these. We'll do the contactum one first, because the contactum one is the only one out of all these MCBs and RCBs that I could not get the head to fit. It doesn't go in, the plastic hole is too small to get this into. So when I tested the contactum one initially, I did a test from the load side here, putting the little copper link into the load side. That one. So tighten him up. It's not supposed to happen, is it? and then I put one on there, and then again I use the crop clip for the other lead to save putting any pressure on this whatsoever, and I can just drop it in on top of the screw there. We take a first reading, that's what I would call the unseated reading, and then I would then actually try and position this and actually make sure that the bit is seated onto the screw head correctly. And in fairness, the instructions and the R1R2 video that they've got out there does show you to make sure that you seat the bit correctly on top of the screw. We'll give it another test. And we get 15.39. So that's how I tested the contactor one. What I then did, because some people in the videos actually asked about testing through the breaker, so what I then did, because I couldn't test from the load side, I reconfigured it and then put the screw head back onto this incoming terminal and just had that through on here. So this time put him on there, so this is going to be through the breaker, and that way around, and you'll actually see the breaker's open. So when I put this on here, I'll just do this one seated, and it's nipping up. Put him in there, make sure he's seated, and then obviously I don't have a test failed here because I've got no connection through. Once I close the breaker up, you can see I've gone green here for the connection. So if you're thinking from the previous reading, I've got 46.70 milliohms on that one. So you can test through the breaker to an extent, but obviously we've got 46 milliohms as opposed to the 15 milliohms that we're getting when we're connected just direct to that terminal. So we'll pop this one out the way. Now all the others, this screw head will go in fine. We've got a Merlin Duran one here, you can see goes in dead easy. Got the Crabtree one there, I think GSH did a Crabtree one, that's fine. This is an Alto one, which is an old WF from Electrical Factors, they all work fine. We've got a BG one here, British General, you can see goes in fine. The RCBO from BG also goes in no problems. We'll do the tests on that one if you like. Just put the bit in there. And I'll put the table up of the test results that I did. You can see the difference between the seated and the unseated tests, and all the unseated tests come out as an increased resistance. So you know that seating this properly on the screw head will affect the result. So again, let's just drop him on, and we've got a circuit in there. I'm running out of battery on the old instrument as well, so there won't be too many more tests. So 66 milliohms on that occasion. Let's seat him properly. You can see 21.98, so much better reading when you seat the screw correctly on there. And the other ones I've got are Hager one here, you can see it goes straight into the Hager, no problems. An MK one, there's another one here, again goes straight in, no problems. And this is a Schneider. To be honest, this is a more industrial one. I have a 3-phase board, but that goes in there okay as well. So you can see from the table that's in there, I then averaged out the non-seated and seated tests. So 83 milliohms for a non-seated, 23 milliohms for a seated test, and you can see the average screw head connection would be around about 11 milliohms. Now obviously I can pick it up with this instrument, but you put 11 milliohms onto the installation test that only has a 10 milliohm resolution anyway, it's not really going to have any significant impact on the reading that you're taking using this lead, in my opinion. And just as a comparison, I put a final table up. I actually have these, I believe these were Staubli originally, but I think they've changed the design now. But these are a magnetic probe tip, the standard 4mm accessory as well. In that table that I put up, you'll see I had even more difficulty getting these into some of the MCBs. They will fit on a Hager, will fit in there, but it didn't go into all of them. And you can see that all the test results that I did with these, the reading was much greater using these than it was using the R1R2 lead in there. And these, if you're worried about the price on this, then yeah, don't go around looking at the price of these, because these are horrifically expensive. And then what else would you do? Oh, we'll just try, whilst we've got a bit of battery left in the old instrument, I will just try this. This is so the board that Mr. Wayne worked on was actually a had old, I think they were Crabtree on that one, slotted head screws, which is just not ideal for this design. So we'll just give him a quick try. If we can get a screwdriver in place. Let's tighten him down. Again, we'll stick him on there. Lead back on, and we'll drop him on there. We'll see if it will stay. Try again. We'll drop him on there. So 350 milliohm on that test. So you can see with a slotted screw, it really isn't very good. Oh, we're going 60 milliohms that time. So you can see quite an erratic result when you're using this on a slotted screw head. Yeah, so for me, it's a pretty well built lead. It doesn't seem to have too many issues with it. The only issues I've really found is if you're using this on breakers with a smaller posi head, which this physically won't fit in, or you've got a slotted head, an MCB or an RCBO with a slotted screw on there, which again I think is quite rare nowadays anyway. It'll just be your older installations that have these. Then this does have issues. Whether the company intend to bring out a version with a number 1 posi that will go into the smaller ones and maybe a slotted to cover off the older breakers, that would again give the electricians working on that kind of equipment the option to use this lead. But if you've got a breaker that takes a posi 2-bit and you can seat this properly, I think this lead works pretty well, and the slight increase you get in resistance shouldn't affect a multifunction installation test. I can pick it up with this instrument because this instrument is designed to make much lower resistance readings, way beyond the capabilities of a standard installation tester. So yeah, the tests I've done this seem to have worked out pretty well, really. With regards to parallel earth paths, I'll try and cover that off in a separate video, see if I can set up some demonstrations of where that's an issue. It can be an issue, but it would be very much be installation dependent. Certain circuits in a domestic environment that you'll get parallel earth paths with, the vast majority you probably won't. If you step up into commercial and industrial, then the likelihood of parallel paths probably increases a bit more, and you'll need to be more careful when using this in the manner that's prescribed in the instruction sheet. But other than that, they seem to have come out with quite a useful little lead, really. As I say, I'll leave links to the lead itself, where you can buy it from, and all the other videos that I've watched out there in the description below. That's pretty much it for this video. Thanks for watching. Hope you found it useful, and I'll see you again in the next one.